All right, let's finish up this 4-1. It's been almost 2 weeks since we've talked about this, but that's okay. We got a couple corollaries here. Let's just go through this fairly quickly. Oops, I got to turn my graphics tablet on. It wasn't on. A corollary. Have we talked about corollaries before? A corollary is basically a theorem. It's just a theorem that has to do with a bigger theorem. So you got this daddy theorem, you got these little baby theorems, okay, that go underneath, okay? So the daddy theorem, or the mama theorem, or whatever you want to use, is, shh, I didn't ask for comments, just listen to me. Guys. So you had the big major theorem, and then you got little theorems under it that has to do with the major theorem, all right? They're corollaries. That's what a corollary is. It's basically just a theorem is all it is. So let me change this so I can write on this thing. Let's click that. Come on, click. There we go. All right, now we're ready to go. Let's make sure it writes. It does. Okay. The first corollary. Let's write the word corollary down. All right. Let's stop making those noises, please. Let's pay attention. Let's act like real students, please. Let's not act like little children. It'd be really nice. You're acting like a little child by yelling out stuff like that. So you prove my point. All right, the first corollary that we're going to do says this. It says the acute angles, let's write it down. I think it's probably good to write it down. The acute angles of a right triangle, I'll just shorten right triangle. The acute angles of a right triangle are, I don't know if we've used this word before, but we're going to use it now. Complementary. We have used supplementary. Do you remember what supplementary meant? That's right, when two angles add up to 180. Okay, complementary. I don't know if you've used that yet or not. But complementary, what do you think? I don't know. There's probably no reason you would know this, but complementary means they add up to be not 180, but they add up to be 90. Okay, so they add up to be 90. So it says the acute angles of a right triangle. Let's just draw a right triangle. And let's look to see which ones are the acute angles. All right, so that's a right triangle right there. If I put that little box, now it's a right triangle, okay? What does this corollary say? What does this little theorem, this little baby theorem say? It says the acute angles of a right triangle. Well, I got a right triangle. Which one are the acute angles? Well, let's try to make this right better. There we go. A, B, C. All right, which one are the acute angles? A and C. Angle A and angle C are the acute angles. So what does this theorem say? What does this little corollary say? That the acute angles at angle A and C are what? Complementary. So what does that mean if they're complementary? Does it mean they're equal? We just said it. What did we say complementary means? They add up to what? To 90 degrees. Very good. They add up to 90 degrees. So that means that angle A, it's with my pen today, it's acting strange. Angle A plus angle what? C is going to equal what? No, well, technically that's true, but give me a number. They're complementary. What do they do when they're complementary? They add up to 90 degrees, okay? So you're right that angle A plus angle C will equal angle B because angle B is 90 degrees. So you are right on that. That's not a wrong statement. But there we go. Now, why is that true? Yeah, so we know B is a right angle, so we know that's 90 degrees right there. That's exactly right. So watch. Angle A, this is like a little mini proof, okay? It's not a real formal proof, but it's kind of a proof. So you know that angle A plus angle B plus angle C equals what? 180. And they tell you it's a right triangle. And they tell you that angle B is what? 90 degrees. Agreed? All right, so watch. Angle A plus angle B, which is 90 degrees, plus angle C is equal to 180. So what am I going to do with that 90 right here? I got a 90 here and a 180 here. What am I going to do? That's it. Subtract a 90 from both sides. So if I subtract a 90 from both sides, look what I get. I get angle A plus what? Angle C equals, what's this? It's 90 degrees, isn't it? Just what I said it was before. This is kind of like a little proof. All right, it's not a formal proof, but it's kind of a proof. It's the thought process of a proof. All right, so I know all three of them add up to 180. Do you understand why this is a corollary? Because this is like a little baby theorem to the big mama and daddy theorem. What's the big mama and daddy theorem? The theorem says that all three angles of a triangle add up to be what? 180 degrees. That's the main theorem, okay? This is kind of like a little offshoot of it. Does that make sense? Because if you know that they add up to 180, take away a 90 from it, what's left? These two angles right here, they have to add up to 90. And that's what this corollary says, that the acute angles of a right triangle are complementary. Was there a hand up over here? No. I'm just showing you why. This is not it's not an example. It's not a test question. I'm just showing you why that this is true right there. That's all I'm doing, okay? Won't be on a test, won't be on a homework or anything like that. But that's what we do in here. All right, let's do another one. Let's say we had an equiangular triangle. I think we've already discussed this before. I'll tell you what, let's go to this. No. Let's click on that. Let's make that a triangle. There we go. That's what I want. Oops, let's click that. All right, I'm going to push this over off to the side if I can grab it. There we go. All right, I specifically made this so that it's an equiangular triangle. Okay, again, let's use DEF instead of ABC. DEF. Everybody with me on that? So it's equiangular, which means what? All angles are equal, right? Okay, so this angle and this angle and this angle, they all have one arc. So what does that mean about all three of them? It means they're all the same, right? They're all equal to each other, okay? So let's do this. If they're all equal to each other, let's give it a variable. Let's just call it x. We'll call it x degrees. Everybody with me on that? This is x degrees. And if they're all equal, what's this going to be? It's also going to be x degrees, right? I'm not going to make one y and z or anything like that, because if they're all the same, use the same letter for all of them. You with me? Now, what's our big theorem? This is another corollary. This is our second corollary. What's our big theorem say? It says that all three angles in any triangle add up to what? Add up to 180, okay? So let's add these up. So I've got angle x plus what? Angle x plus angle x. And what should they add up to be? 180. So that's nothing new right there, right? That's from the original theorem that says all the angles of a triangle add up to 180 degrees. But let's do this. Let's actually solve for x. And I can actually find what each of these angles is going to equal, right? And you probably already did it in your head. We might have already talked about it. I think we did. I think we may even talked about what each of these are. Don't give it away if you already know. All right, but let's do the math. Again, this is kind of a proof, kind of. So if I take x plus x plus x, what's that equal to? 3x. Okay, do you agree? 1x plus 1x is 2x plus another x is 3x. And that equals what? 180. Let's find what x is. What do we do now? Divide by 3. Divide this by 3. That cancels out. So what's x equal to? 60, that's right. So that means that every angle inside of this equiangular triangle equals how many degrees? 60 degrees. So that's 60, this one's 60, and this one's 60. Does that make sense? All right. We could have probably figured that out in our head, right? Because we know they're all the same. And if they all add up to 180, and if they're all the same, we just take 180 divided by 3, which gives us 60, right? We could have done that, but I just showed you algebraically how it actually works, okay? And that's that theorem. That's that second corollary. So this is a second corollary. And it just says that, let's write it down since we wrote the other one down. It says each angle in an equiangular triangle, and let's jump down here, equiangular triangle equals what? What does each angle equal on any equiangular triangle? 60 degrees. It doesn't matter how big, doesn't matter how small. Okay, as long as all three angles are exactly the same, every single one of those angles is going to be 60 degrees. What if I didn't know it was equiangular, but I knew it was equilateral? It's the same thing. That's right, because if it's equilateral, if this side, and this side are all equal to each other, what does that automatically make the other three angles? Equal to each other as well. Okay? So if it's equilateral, it's equiangular. If it's equiangular, it's equilateral. Okay? So even if they didn't tell you the angles are exactly the same, if they just told you the sides were exactly the same, so if they told you that side was 5, this side was 5, this side was 5, and they ask you to find the angle, okay, does that 5 really have anything to do with it? No, it just shows you that they're all the same, right? And if all three sides are the same, that means all three angles are the same. If all three angles are the same, right, 60 degrees. Got it? Yeah. Fill out your book. Everybody good so far? Yeah, that was pretty easy, right? So let's now move on. Sign this. There we go. Now we're going to basically do something quite a bit different. So I'm going to draw a little triangle here. And, oops. There we go. Let's just draw it like this. And let's draw it like this. Okay. I'm going to group them together. Control G will group it. Then I'm going to copy and paste it. So I copied and pasted that triangle. So what do you think is true about these two triangles? Parallel? You can't have parallel triangles. Come on, what have I been teaching in here? They're not just equal to. Give me a better word than that. Come on, we've talked about this a lot. Supplementary? Now you're just throwing out words that you don't know what they mean. What's true about these two triangles? We don't say they're equal to each other. What do we say? They're congruent to each other. That's right. Actually, I'm going to flip this. Let's see. How do I flip it? I think you go to transform. Nope, don't go to transform. Oh, yeah, you do. No, don't go to that. Oh, maybe you go here. Ah, there we go. So, yeah, let's flip it vertically. All right, there we go. It's good enough. And now this actually does have something to do with what we were talking about. Call this angle A, B, and C. I'm going to flip this around. I'm going to twist it around a little bit like that. And let's say this is Y, this is X, and this is Z. And if I did this right, angle A and X are equal to each other, and angle B and angle Y are equal to each other. Okay? What I want to decide is, what's the relationship between angle C and angle Z? You might be able to look at it and just take a wild guess. And maybe it's not a wild guess. Maybe it's a pretty informed guess. But what do you think might possibly be true about angle C and angle Z? They're equal to each other, probably. Looks like they probably would be, right? Right? If A and X were equal to each other, if B and Y were equal to each other, it looks like C and Z would be equal to each other, doesn't it? Yeah. So let's do some math and do a little proof. I know we said we weren't going to do proofs. I'm not going to give you proofs on a homework or anything like that or on a test. But I think it's good to see the reasoning behind what we're doing right here. Let's do this. Tell me if this is true. If I said angle A plus angle B plus angle C equals, now remember, what do all three of these angles, A, B, and C, add up to be? 180. What do all three of these angles add up to be? 180. Would you agree? So I could write angle A plus angle B plus angle C equals, what do you think here? Angle X plus, not XYZ, angle X plus angle what? Y plus angle Z. You could do that with any triangles, couldn't you? Any two triangles. Doesn't matter what they look like. They don't have to be congruent or anything. Any two triangles, the sum of the angles of this triangle is always going to equal the sum of the angles of this triangle, because the sum of the angles of any triangle always equals what? 180 degrees. You with me? Okay, so you agree that's true? But there's something special about this. It says that angle A is equal to what over here? Angle X, right, because they both have that one arc, okay? So they're equal to each other. So watch what I can do. I can do a little algebra. If they're exactly the same, remember in algebra, I could get rid of something on one side as long as I do the same thing on the other side. So if I subtract an angle A from this side, what can I do over here? Subtract what from this side? Angle X, because they're exactly the same. Would you agree? Like if this was 30 degrees, then I could, and this was 30 degrees, I could subtract the 30 from both sides, couldn't I? Okay. What else could you subtract? The B and the Y. That's right. So watch. Angle B and angle Y, they're equal to each other, so I could subtract them from both sides. What am I left with then? So we just proved that angle C is going to equal angle Z. That's what we were trying to, I mean, we kind of figured it would, right? That C and Z would be equal to each other. We kind of figured that would be true, but this is why, right there. All right, do you like doing that stuff? Yeah, I think it's kind of cool. All right, now we're going to do a real example. Okay, now all this stuff just kind of leads us into what we're going to do now. So let's do it. All right, it's in the book, but you could draw it. It's not that much. I'm going to draw it, so if I can draw it, stop doing that. There we go. This is going to go to about right there. And this is going to go from there to there. All right, everybody draw that triangle. It's an obtuse triangle. And I'm going to put some other stuff in here. Yeah, there we go. All right, I put that little line in there. And then they give us some information. They tell you that this is 36 degrees. They tell you this one down here is 60 degrees. They tell you this one is 45 degrees. And you need to find the following three angles. You need to find angle 1, you need to find angle 2, and you need to find angle 3. So you should be able to do this with all the information that we've done. Matthew, you want to get that door? He's zonked out. All right. Let's do angle 1 first. Okay, so angle 1 equals, I'm going to put question mark, okay? Trying to find what angle 1's equal to. That should be pretty easy for you, but let's show all the steps. So look. Angle 1 is part of a triangle, isn't it? Part of this little triangle down here on the bottom. You got the angle 1, you got the 36 degrees, you got the 60 degrees. So what's the math involved to find angle 1?
You add up all of the angles to...
That's it. Okay, so let's do that. So angle 1 plus 36 degrees plus 60 degrees equals what? 180 degrees, right? Because we know that all three angles in any triangle always add up to 180. So always look for that. Now we got to do some math. So we're going to solve for angle 1. Got to do a little algebra. Yeah. Caleb. Yeah, we will. Let's add them up. Yep. So let's add these two together. So what's 36 and 60? 96 equals 180. And you said it. You subtract 96 from both sides now. Everybody see that? Subtract 96, subtract 96. What is that? 84? Okay. Oops, angle 1 is equal to 84 degrees. So good. We're done with that one anyway. So that's 84 degrees. Now, you could do angle 2 real easy, or you could do it as a two-stepper. Actually, either way, you could do one step. You could find angle 2 two different ways. Each one Each way only has one step. So angle 2. How would you find angle 2? Go ahead, Anna. Did you want it? Go ahead. Tell me. How would you do it, Amy? Minus 45? Nah, not minus 45. Okay, because this and this don't add up to 180. Now, all three of these do. 2, 3, and 45 add up to 180. But you don't know angle 3, though, do you? So you can't do that. I'm looking at a couple things. I'm looking at this. It's probably the easiest way to see it. So what's that whole thing right there? It's a straight line. So how many degrees is that? 180, right? It's a straight line, 180 degrees. Agree? So if this part's 84, how do I find what's left over? Just subtract. Okay, so I'm finding angle 2. I'm going to put angle 2 equals question mark. So you could just go, what? 180 minus 84. And you'll get 96. All right, so that angle, angle 2, let's get rid of that big old line right there. And let's get rid of that circle. So angle 2 is now 96 degrees. What's another easy way to get 96? Remember I said there was 2 ways to get it? What's another easy way? It's a way that students forget all the time, but we talked about this. Do you remember? Remember we talked about exterior angle and remote interior angles? Is that ringing a bell?
I don't think remote interior.
I think we did. Didn't we? We didn't do that?
It was.
Oh, maybe we haven't got to it. Maybe I'm thinking the other class, because the other class has gone through this. So maybe this is, oh, you know what? I'm looking at my notes. It's the next thing. Good. So this is 84 degrees. This will kind of lead us into the next little section, okay? Sorry about that. You guys didn't know that. So right now, you only know one way to do it, and that would just be taking that away from 180. But look, this is 96. Look at this number and look at this number. What could you do with these two numbers? You could just add them up. That's right. Okay, if I just add these up, that's going to equal this angle right here. So that'd be kind of easy, right? But you didn't know that before. You're going to know in a few minutes because that's the next thing I'm going to teach you. Sorry about that. All right? Everybody see that? All right, because what we're going to do after this example is that thing right there, okay? So we'll talk about it. These are called remote interior angles. It's called an exterior angle. I'll make it a little easier for you when we go through it. But that's kind of cool. Now, angle 3 should be fairly easy now. So angle 3 equals question mark. So angle 3 is part of this triangle. It's actually part of the whole big triangle, but I would just use this little triangle up here, wouldn't you? It's got 3 angles. Now I know these 2 angles. Now I can find angle 3. So what am I going to do? I'm going to say angle 3 plus what?
96.
Plus 96 plus 45. What do they add up to be? 180. Okay? And now let's go ahead and do the math. 96 and 45, what's that? That's an 11, that's a 13, 144, is that right? 141, sorry. 141. Oops, I put equals here. Why did I put equals? Getting ahead of myself. Sorry about that. Equals 180. Everybody see what we did? Just added up 96 and 45. Now I can do what to 141? Subtract it. Subtract it. And then angle 3 is equal to, what's that? 39 degrees. And there we go. So there's angle 1, there's angle 2, and there's angle 3. So that little angle up here is going to be 39. I'll put a little arrow. That's going to be 39 degrees. That's absolutely something that you're going to see on a homework, okay? They're going to give you some angles, they're going to give you some missing angles, and you just try to use that 180 thing to find the missing angles. All right, let's do that thing I was talking about before. That 96, right, is 36 plus 60. Let's see why that is, and it's something that you can use quite often. A lot of students forget to use it, but it's pretty helpful. So let's do that. And let's do this. All right. So let's put some numbers in here. We'll call it 1, 2, and 3. So this is angle 1, this is angle 2, this is angle 3, and this is angle 4. Now, it doesn't mean it's 1 degree, 2 degree, 3 degrees, right? It's just the name of the angle. That's all that is. All right, so let's, what do we get out of here? I always forget. This is 150. Why do I always think it's 145? Do we get out 145? Was it last year? 215. It's not even the Wednesday schedule. I don't know. Oh, college algebra. 5th period on Wednesdays, 45. Maybe that's what I'm thinking. I don't know. So we got till 50. Good. I got some time. So let's take a look at this. I got a triangle. Then I extended one of the sides. So angle 4, is angle 4 inside the triangle? No, it's on the outside of the triangle. So what kind of angle are we going to call this? An exterior, right? Exterior angle. All right, it's outside the triangle. Now, what about 1, 2, and 3? They're inside the triangle, so all 3 of those angles are considered what? Interior angles, okay? But I want you to look at angle 2 and angle 3. See how angle 1 is right next to angle 4? And then 2 and 3 are further away, right? From angle 4, further away. When you watch TV, you guys grew up your whole entire life with what in your hand when you're watching TV? A remote, okay? Back when I was a kid, guess what we had to do? This is really traumatizing for you guys, okay? We actually had to get up off the couch, walk over to the TV, and go click, 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 and change the channel. You didn't have to move it too many times. We only had like 5 channels altogether, so it wasn't that many clicks. But we'd have to change the channel and then go back. And then they came out with a remote, so now I can be, do I have to be really close to the TV and touch the TV? No. Now I can be what? Far away from the TV. That's remote. Everybody see that? Okay, that's why they call it a remote control. Remote. If you live in the remote part of Canada or the remote part of Alaska, what does that mean? Far away from everybody else, okay? So remote means far away. So 2 and 3 are what to angle 4? They're far away, right? They're remote. And they're interior. So what do we call them? The remote interior angles. Remote interior, if I could write. It's been 2 weeks since I've written on this thing. Remote interior angles. So angle 2 is a remote interior angle, and angle 3 is a remote interior angle. Not angle 1. Why not angle 1? Because it's what? It's right next to angle 4, okay? Everybody with me? Did we talk about adjacent? Did we use that word yet this year? Okay. Well, angle 1 is adjacent to angle 4. It's right next to it, okay? All right. So we have a little theorem. It's called the exterior angle theorem. I'll just write that down. The exterior angle theorem says that the exterior angle is equal to the sum. What does that mean? Sum. You add them up, right? The sum of the remote interior angles. So that means that angle 4 is equal to, that's the exterior angle, right? It's equal to what? The sum of the remote interior angles. So which ones are my remote interior angles? 2 and 3. What does the sum mean I do to them? I add them up. So it's angle 2 plus what? Angle 3. All right? That's what the exterior angle theorem says. Let's go back to that problem that we were doing before. Look at angle 2. Do you see angle 2? It would be like this little triangle down here, and you extended one of the sides. So 96, even though it's inside of this triangle, okay, is it inside this little triangle right here, though? No. So this is an exterior angle, isn't it? It's exterior to this triangle. Which ones are the remote interior angles? The 36 and the 60, because they're the ones that are further away. You see it? The 84 is right next to it. So what does our theorem say? Our theorem says that the exterior angle is equal to the sum of the remote interior angles. So all I had to do was just go 36 plus 60. Boom, I got 96. Good.
Now you can say something. Now that you said the remote thing, I can see that angle 3 and
Good.
45 is the same for 84.
That's exactly right. We got another exterior angle, don't we? Angle 1 right here is an exterior angle to this triangle right here. So what's the remote interior angles to this triangle right here? This 39 and this 45. Excuse me. All right, so what's 39 plus 45? That's 84. That's right. And it works, doesn't it? All right, it's kind of cool. It's probably something you'd never thought of, right? Just by, putting in the numbers here, probably never would have seen that relationship. But that relationship is pretty important. We're going to use it a lot. Sometimes it helps out. Sometimes it makes things a lot easier. So let's do, this is the last thing. Right on time. I'll just redraw that triangle again. So let's draw pretty much the same triangle and exterior angle. But this time we're going to be a little bit tricky. When they just put regular numbers in there, that's pretty easy, right? We want a little more of a challenge. So they are going to tell you that this angle up here is 64 degrees. So that's nice. But here's where they get weird. They tell you this is 5x plus 3 degrees. And this one, this exterior angle, is 13x minus 5 degrees. And what we have to do is we got to find all the missing angles. Okay? Everybody with me? Just call it, let's do the same as, this is x, this is w, this is y, and they put a point right here, and they call that point z. All right, let's do this together because you're going to have some problems on the homework that are like this. This is kind of like the 21 to whatever, 21 to 29 kind of stuff, okay? So where do we start? How in the world am I going to solve for x? Well, I got to set something equal to each other or something equal to something, right? I've got to have some kind of an equation. So where do we get it from, Amy? Go ahead. You're close, but not quite. Kate, help me out.
5x plus 3 plus 64 is equal to 3x plus 9.
13, right? You got it. Exactly right. This is an exterior angle, isn't it? Mm-hmm. What are these? Give me the name. Remote interior angles. So what's the theorem say? The theorem says that the exterior angle is equal to the what? The sum of the remote interior angles. That means you add these up and you set it equal to the exterior angle. So let's do that. Let's add these up. So I'll tell you what, let's do it this way. Since 13 is bigger, let's put that on the left. Is that all right? All right, so 13x minus 5 is equal to, so this exterior angle is equal to what? The sum, right, of these two angles right here. You've got to add them up. So let's just add them up. 5x plus 3 plus what? 64. 67? There's no 67. But the what? Oh, well, I'm writing it down. I'm not going to skip that step. I want to write this down, then I'll make it 67, okay? I don't want to skip ahead. I want to show all my steps. Everybody with me on that? That was the geometry. Okay, once you know that, the rest is just doing a bunch of algebra. All right, so that's why you learned algebra before you took geometry. Let's do this. 13x minus 5 equals 5x plus what? 67. Am I right? Subtract 5x from both sides. I'm not going to go through my algebra explanations, just going to do it. I'm going to add a 5 to both sides. And that's going to give you, what's that? 8x equals, what's that? 72. Divide by 8. What's x equal to? 9. Okay. It's not really what they're asking for. Okay. They're asking you to find all the missing angles. So now what can you do? X is 9, so you can put it in for this. Let's just do this in our head. 5 times 9 is? 45. Plus 3 is? 48. So that angle's 48. Put a, I don't know if you can do that in your head, but you could just add these up and it's going to equal this angle, right? So let's add up 64 and 48. So what's that? That's 12. That's 10. That's 11. So what's this equal to? 112. Okay? And then you can find this. How can you find this angle right here? If you know this is 112, you can find this with one step. Subtract it from 180. That's right. So 180 minus 112 is, what's that? 68? Is that right? 68 degrees. It should give you 112. So I don't have a calculator. I can't do that in my head. 13 times 9, I should be able to do it. 13 times 10 is 130. Minus 13 is 117. Minus 5 is 112. Yeah. Okay, so it does work, doesn't it? So I could have put x in, but to me it was a lot easier just adding 64 and 48. Would you agree? Yeah. All right. So here's your homework. Well, you know what your homework is. I told you already, right? What is it, 1 to 13?
113 and 21.
21 to 20 what? 29. It's section 4.1, so just look under section 4.1 and do those problems.